In this video, we're going to talk about how we figure out the remaining loan balance due at a given time. So you might want to pause now, write this down, and then we'll have a chat. So you should recognize this example from the first video. Going back to your example where we borrowed money from a friend and you paid back the friend in installments 1 year, 2 years, 3 years, and 4 years from today. So we want to figure out what the balance of the loan is in 2 years. So looking at our time value diagram again, we've got these payments that we've already made, the 300 and the 200. We've made that up until time 2. And then we've got these remaining payments of 500 and 400 that your friend hasn't paid back yet. Or sorry, you haven't paid back to your friend yet. So if you want to figure out what you owe your friend today, what's the remaining loan balance, there's a couple of ways you can compute that. One of the reasons why you might be interested in this is when you pay off a loan, you might want to pay off the loan early. Maybe you've saved up so you can pay off the loan early. Maybe you've come into some inheritance. Whatever the reason, you might want to pay off the loan early. If you want to pay off the loan early, you need to know how much balance is remaining on that loan to be able to do so. So there's a couple of ways that we can look at this particular idea of what's remaining on the loan based on what's still to come, what payments are still coming in versus what has already happened. So those two different methods of looking at the balance are referred to as the prospective method and the retrospective method. So the prospective method is basically what you mean, what it sounds like. It's looking forward. What payments are still to come? So the prospective method of figuring out a balance at a given time is the present value at the given time of the remaining payments that are still to come. So that's one way of looking at figuring out the loan balance. So let's just go through that for this example. We want to know what's the balance of the loan after 2 years. Using the prospective method, if we want the loan balance after 2 years, so this L sub 2 notation, if we want the loan balance after 2 years, according to the prospective method, that's the present value at time t equal to 2 of the payments after t equal to 2. Well, we know that there are 2 payments remaining after time 2. Those are the payments of $500 and $400 respectively. We need to move the $500 back 1 time period and the $400 back 2 time periods. We're not calculating the present value all the way back at 0. We're calculating the present value at time 2. So the $500 gets stepped back 1 time period, the $400 stepped back 2 time periods, and in that case you get a balance, a remaining balance of $827.70. So if you wanted to pay your friend off early, you remember that back in video 1, the loan was about $1,200. It was $1,197 and change. To pay your friend back early, you would need to pay $827.70, which makes sense. It passes the sniff test because that's actually less than the $900 remaining that you would pay over the course of the next 2 years. So that's one way of looking at how to do the balance of a loan at a particular time. That's the looking forward, the prospective method. We can also look back at what's already happened. That's our retrospective method. So let's think about how the retrospective method works. There's a couple of things that go on with this method. One of them is that you've got an initial loan value. If it's been sitting there up until time t, that initial loan value accumulates interest over time. So part of the retrospective method is looking at the accumulated value of the initial loan value at the given time. But that's not the only thing that's happened. We've also made payments up until time t. So we'll subtract off any accumulated value of any payments made at time t or before time t. So let's look at what happens here with our retrospective method for this particular example. So the loan value at time 2, the balance at time 2, so L sub 2, should be the accumulated value of the initial loan amount at time 2 minus the accumulated value of any payments that were made up until time 2. Well, again, remembering back to the first video, the original loan balance was $1,197.67. That's over here at time 0, just to write that on our time diagram. We've got to have this move over to time 2. We've got to accumulate that for 2 years. To do that, we'll use our interest rate, the 1.06 squared in this case. This represents our accumulated value of the initial loan amount. We also need to subtract off anything that's gone on before time 2, or up to time 2. Well, there was a $300 payment that was made at time 1. That needs to get moved forward to time 2. So we'll take the 300 times 1.06 to the first power. And then we've got the $200 payment that's at time 2, so it doesn't need to be moved at all. So we just need to add 200 in there. And then we need to subtract these two things. When we do the subtraction, we notice that we get the same exact amount that we got from the prospective method. Now, depending on problems that you're given for exam FM, you may need to use one over the other. They should always give you the same value, but sometimes in some problems, you're not given enough information to do one of the methods. You have to do the other. So you do need to know both of these methods going forward for exam FM. Now, again, just like we mentioned in the first video in this series for Chapter 11, most of the loans that you come across are for level payments. So if we think about a time value diagram here for level payments, so we have n level payments, all of the same value PMT, and we're interested in this loan value here at time t. Using the same concepts that we just talked about, the prospective method says that the loan value at time t, looking forward past time t, that should be equal to the present value at time t of the payments after time t. So we're looking at this block of payments past time t, and we need to step it back to time t. Well, we notice that if we're sitting at time t, this is essentially the present value of an annuity immediate. Each of the payments are at the end of the period, and we want to step it back to time t. How many payments are remaining? Well, we've already had t out of the total of n. So there's still n minus t payments here at the end. So when we're looking at the present value for this particular annuity, we would use our A angle n minus t for an interest rate of I. This is your present value of an annuity immediate at time t for those remaining n minus t payments, and we'll multiply it by the payment amount. So this first equation in the box here is the prospective method for finding the loan value at time t. For retrospective, remember again, we're looking back for retrospective. We look at the accumulated value of the initial loan amount minus the accumulated value of any payments at or before time t. Well, if I look at those payments, we notice that again we've got this annuity immediate because all these payments are coming at the end of the time period, and we want accumulated value. So the accumulated value of the payments at or before time t is going to be the accumulated value of an annuity immediate for those t payments. So that's where this S angle t part's coming from. We need to multiply it by the payment amount. This part, the second part in this formula, is representing the accumulated value of the payments. We need the first part, the accumulated value of the initial loan amount. Well, that's just taking your 1 plus I, raising it to the t, and multiplying it by your initial loan amount. So the second formula in the box is the retrospective method for looking at a loan balance at time t for a level payment amortized loan. So these are the two formulas that you'll probably come across most often for exam FM in these types of problems. And in the next video, we'll go through an example of computing balances in this fashion.